Hey, geometry students, we are up to day 3-7, where we get to talk about one more new method that you can prove triangles congruent, and it's called hypotenuse leg. So we abbreviate it just to like HL, sometimes with a dash between, sometimes not. So the new method, when we put a little HL right here, and we know what it stands for. Something to keep in mind is that triangles only have a hypotenuse and refer to legs if we are talking about a right triangle, right? So when we say, all right, what would you have to be given in here? We would have to know a couple of things. So first of all, if I look at the diagram, we can probably assume that this would be, the right angle down here, just based on the way that it's drawn. So that if I were to give you BC is congruent to EF, we wouldn't maybe initially know that that would be a hypotenuse, but if you were to mark it like with an S, later on you could come back and say, oh, just kidding. That was the hypotenuse of each. So if I give you this, and then one of the legs, so like let's say BA is congruent to ED, again, that might just seem like any old side, but once we put it all together, we would recognize that, all right, that's the leg of a right triangle. So when I say we put it all together, the third piece, since it's usually like angle, side, angle, is that you'd have a hypotenuse congruent, a pair of legs congruent, and that you would know that it's a right triangle. So we would be able to say that triangle ABC and triangle DEF are right triangles. That's sort of that third key step that you need. Once we could say this, then we'd be able to say that triangle ABC is congruent to triangle DEF, and our reason would be that the hypotenuse and leg of one are congruent to the hypotenuse and leg of the other. Right? So down here, when it says HL can only be used when both of the triangles involved are right triangles. Super, super, super important here. Right? So down at the bottom, when it says determine whether or not the triangles shown are congruent, well, with the very first one, keep in mind that we could use a little reflexive property right there. And so then if I cover up one of the triangles, so I could just focus in on one, I've got an angle and two sides, but since the angle isn't between it, it can't be side angle side. But since it's a right angle, this would then be the leg across from it. Excuse me, that's the hypotenuse. So we could say yes. Right? Yes, they are congruent triangles, and it would be by HL. All right, so there's a perfect example of that. For the second one, we don't have any vertical, we don't have any reflexive, so I'm just going to cover up. If we look at this, we do have a nice right angle, but we don't know the side opposite of it. So this is definitely not hypotenuse leg. What we're really looking at is just side, angle, side, because it's the angle in between the sides. All right. When we take a look at number 3, first things first, the fact that the triangles are next to each other means we're going to get that reflexive side in between them. So I'm going to mark that before I cover up one of the triangles. Then when I cover up, I've got my right angle, and I have two sides. But here's my right angle. That's the side opposite, so that's my hypotenuse. This would be my leg. So we could say yes, right, that they are congruent triangles. And it'd be by HL. All right. As for the very last one, I have that little reflexive piece again. And if I cover up, I've got an angle and then two sides, but it's not a right angle. So the fact that it's not a right angle means that's not a hypotenuse. And that wouldn't be considered like the leg of a right triangle. And ASS we talked about is not a thing. So we would say no, that they are not congruent triangles, right? And if you want to, you can put, because angle, side, side doesn't work. All right, now that it doesn't work just because it says something naughty. It's because it legitimately doesn't work. I could show you with constructions why angle, side, side isn't enough. Reason is you could end up with two different triangles that have a pair of congruent angles and two pairs of congruent sides, and they would be completely different triangles. So that's why it doesn't actually work. All right. So let's actually try this out. So onto the next page. It's helpful to see like, how do you get that right triangle step? So here, we're going to start just like we would with any proof with our given. So we have BD is perpendicular to AC. And because perpendicular is a vocab term, I'm going to stop with that first given, and I'm going to follow through with step 2, talking about that given. So perpendicular lines implies, all right, this doesn't change. Perpendicular lines still implies that we have right angles. And then in the picture, if you trace over the perpendicular lines, it'll actually outline the right angles. So BD is perpendicular to AC. Right there, you can see that perpendicular symbol pop up in the diagram. So there's our right angles, all right? So I'm going to say that angle ADB and angle CDB are right angles. And that's because perpendicular lines tells us we've got right angles. All right. Well, now right angles actually presents us with a new vocab term. Right? So when I go on to step 3, here's where things can change. I'm still going to start with right angles. But now 2 different things can happen. We could go on to say that they provide congruent right angles. So it could be that we've got congruent angles. Or it could be that what we want to say is right angles means that we have right triangles. And at this point, you don't really know which way you want to go. Congruent angles would be if it's just going to be like an angle and side angle side. Right triangles would be if you're setting up for HL. Now, because this is an HL lesson, we're probably focusing on that second one. But what I'm actually going to do is for right now, I'm going to leave that step open. So we're going to come back to step 3. Let's see what else we end up with. So if we go to step 4, I'm going to put my other given in here, that AB is congruent to CB, which we could have put back up in the first given. All right, so AB right here, congruent to CB. All right, that's either going to be a pair of sides, or if I cover it up, that would be the hypotenuse. All right. Step 5, I'm out of givens. So look at your diagram. They overlap right down the middle. That's going to be a little reflexive property with BD congruent to BD. Right. And here is where you'd want to assess. Do we have angle side side or side angle side? You would never have angle side side. All right, but let's cover up and take a look. So we have 2 sides, we've got our angle, but if I look at where the angle is situated, it's not in between the sides. The fact that I have a right angle and I have the side opposite, which is the hypotenuse, and I have the side next to it, which would be the leg, we're going to be using HL here. So how we finish out this proof is that perpendicular gave us right angles. Right angles is going to give us the fact that we have right triangles. So that's what we're going to put over here, that triangle ABD and triangle CBD are right triangles. Right? That is our key little step. So maybe put a little star next to it. Then what that really means is that when we say that AB is congruent to CB, that is the hypotenuse, and then BD being congruent to itself, that's your leg. Right? So it's super helpful to just keep track of these things. Also, it makes sure that you get them into the proof themselves. Sometimes you see them, and then you get ahead of yourself, and you're like, oh, triangles are congruent, and we didn't actually get those items into the proof. So it helps us keep track. All right, we're allowed to now say that triangle ABD is congruent to triangle CBD, and our reason would be hypotenuse, leg. So the hypotenuse and leg of one triangle are congruent to the hypotenuse and leg of the other triangle. Done. All right. So since it's a little different, I'm going to make sure that we do a couple more that are similar to this so that you can kind of get the hang of it. Now, back in my proof, do I really want that double angle? No, I wouldn't really need this part. All right. So I could get rid of that. So in the future, you have an option. You could leave it open and fill it in once you know, or you could do both steps. You could say that Right angles gives you congruent angles and make that step 3. And step 4 could have been right angles gives you right triangles and made that step 4. That would be perfectly fine as well. So let me slide on up. Let's take a look at this next guy here. So again, we're going to try to show that the two triangles are congruent. So triangle ABD and triangle CDB over here. Ooh, Teddy's trying to get in the Halloween candy. Get out of there, buddy. All right. So we've got our givens, but the first two givens are both talking about perpendicular. So let's put those together. So AB is perpendicular to BD, and then CD is perpendicular to DB. All right. Given. Let's go mark that in the picture. So AB is perpendicular to BD, and CD is perpendicular to DB. Okay, you can see those right angles forming in there. And lucky for us, that's what perpendicular says. So perpendicular lines implies that we're going to have right angles. Right? And just as we have always, the perpendicular from here is what told us to use the perpendicular right here. All right. So I have to say that I have right angles in the picture. So look closely. I've got this right angle. I've got that right angle. So I can say that angle ABD and angle CDB are right angles. And that's because perpendicular lines implies right angles. So when you read it all the way through, it should make sense. This should be supporting that statement right there. All right. For step 3, we know that we're going to take those right angles and run with it. But just like we said last time, we're not really sure what we're going to say. So if you want to be safe, we can say everything. Otherwise, you could leave it blank and fill it back in. Let me show you what it'd look like to say everything here. So we would say that right angles implies that we have congruent angles, which means let's state that the angles are congruent. So we would say angle ABD is congruent to angle CDB. All right. That would cover the bases there. Step 4 would be to say, well, what if I need to know the triangles are right? Well, let's get that out of the way. So we can say triangle ABD and triangle CDB are right triangles. And my reason for that would be to say right angles implies right triangles. So if you want, you can just put them both down and then you've got everything covered, okay? We won't know yet until we get to the end which one's the right one, but if you have an extra step that's correct, there's nothing wrong with that. The only problem with having an extra step is if it's incorrect. If you like make something up that's wrong, then it would be bad. But if you're just giving me an extra fact that happens to be true and I just don't need it in the end, all right, it's like bonus fun facts. All right. Let's keep rolling and see what we need. So the next given, we've got AD is congruent to CB. So that's a given. I'm going to mark that in my picture. AD is congruent to CB. So up in the diagram, that's either just going to be a pair of sides, or because of where the right angle is, that's going to be the hypotenuse. Now, when you look, we are out of givens, but in the diagram, we have an overlapping side. We've got this side right here. And so we can say BD is congruent to itself by the reflexive property. So let me slide on down. I'm going to make step 6 that BD is congruent to BD. My dog is like crying out there because my husband left. I don't know if you guys can hear that or not. By the reflexive property. All right. And now let's go look. Cover up one triangle and see what all this stuff means. So if we cover up one triangle here, I've got angle and then side here, side there. It only works if the angle's in between the sides and making it SAS. So this is another case where this is the hypotenuse. That's the leg. So let's go back in the proof and kind of clearly state where we've said that. So we've got right triangles. This is our key step right here. AD being congruent to CB was our hypotenuse. And then BD congruent to itself, that was our leg. All right, we've covered all our bases. So step 3 ended up being like a bonus step. fun facts to share. All right. Lastly, we get to say triangle ABD is congruent to triangle CDB. And finally, by hypotenuse leg. All right. So the reason I keep starting these as if, well, maybe it is hypotenuse leg, maybe it's not, is because other than today, when we're looking at it in the hypotenuse leg lesson, it's not going to be a guarantee that that's what you're being told. You're going to have to reason your way through it. So you may start the proof and kind of like game plan and know ahead of time, or you may take it as it comes as you walk through it. Either way is perfectly fine. All right, that very last proof, if we take a look, all I want you to focus on is that triangle AEM. That's this little guy down here. We're trying to prove that that's congruent to triangle BFM. All right. What I'm thinking is that I would like to save this one to start class off tomorrow. But take a look. You have a whole page because when you look at those givens, you've got midpoint, you got perpendicular, we got some congruent stuff. This is going to be a really involved proof, which I'm excited to look at with you. So note that it's going to be our little recap. And remember, you are joining class every day, whether you're in person or at home. Thanks, guys. Have a good one.